Okay, let us solve this time rates problem. So water is flowing into a conical reservoir 20 feet deep and 10 feet across the top at the rate of 15 cubic feet per minute. Find how fast the surface is rising when the water is 8 feet deep. Okay, so this is a time rates problem, meaning to say we are going to differentiate the variable with respect to time. If we're going to draw first, we know we now have the conical reservoir. The shape is a cone, so something like this. Yeah, more or less something like this. Then it is stated here that the height is 20 feet. So this is 20 feet and 10 feet across the top. So meaning the diameter of the base is 10 feet. But we're concerned for the radius because the formula for the volume of the cone is just concerning radius. So 10 divided by 2 is 5. So R is equal to 5. Okay. Then the question is asking for the rate at which the surface is rising when the water is 8 feet deep. Okay. So we're going to consider another one here. Yan. We'll have this R radius for this, and this is the height. Okay, we're given the rate at which the volume is increasing. So that means we have the derivative of the volume with respect to time, right? That's 15 cubic feet per minute. Okay, then we have the height 8 feet. So we're going to use that height later. Okay, recall, what's the formula to find the volume of a cone? That is 1/3 pi r squared height. Okay? Then, we're going to express the volume as a single variable only. Look at the figure here, this one. As you can see, we have triangle. Like this is R, this is our H, which is similar to the larger triangle. Yan, that which is 20 and 5. We can apply the principle of similar triangle. That is the radius of the small divided by each height is equal to 5 over 20. We're going to solve for r in terms of h because the problem is asking for the rate at which the height is increasing. So r times 20 is 20r, 5 times h is 5h. So dividing both sides by 20 gives you h over 4. So we now replace r by h over 4 in that formula. That is v equals 1/3 pi, r is h over 4, so h over 4 squared times the height. So v is equal to 1/3 pi h cube over 4 times 4, 16, right? So pi h squared times h is h cube, 4 squared 16. Then simplify. So that's pi h cube over 48. So we now have to differentiate this. Okay. So derivative of volume with respect to time. So derivative of h cube because pi over 48 is constant. So pi over 48 constant. Derivative of h cube is 3h squared times derivative of h, with respect to time. Implicit. So dv dt is equal to 3 over 48 16. So 1 over 16. So pi h squared over 16 dh dt. So now we are looking for dh dt. Okay, this is the required dh dt. So what we are going to do here is to substitute. What is our dv dt? So that is 15, right? So 15 pi. What is our h? That's 8. So 8 squared over 16 times dh over dt. Then that is pi. 8 times 8 is 64 divided by 16. That's 4. 4 pi dh dt. Right? Then, what we are going to do here is to solve for dh dt. So we divide both sides by 4 pi. We now have dh dt is equal to 15 over 4 pi. So that's the rate at which the height is, or the surface is rising. Okay, 15 divided by 4 pi, or approximately 1.19 uh, feet per minute. Okay, so this is the rate at which the surface is rising. 1.19 feet per minute. Okay?